In this video I'll be describing this new spring-loaded pen, which is designed for printing patterns on both the faces and sides of projects. Over the past few months I've been trying to develop the optimum pen for printing the patterns for my Rose engine. And I've gone through a number of different designs, each trying to improve on the other and develop a pen that gives me the optimum results. I have two problems that I have to overcome with these pens. And one, it needs to be somewhat spring-loaded, that it keeps a constant pressure on the paper. And the other thing is it cannot move laterally back and forth. Let me go through some of these designs and I'll show you some of the shortcomings in the previous designs that I've worked on. This is one of my first designs, which worked fairly well for printing because it is spring-loaded. This was a block that mounts on my AXA tool post, and I have a pen that goes inside here, and I have a spring on the bottom, so that this does have a little bit of spring to it. So it's a little bit jerky, but it does work pretty well. But the problem is that this pen moves back and forth, this way, laterally. So as the spindle is turning, it does give some movement to this, so it's not a perfect solution. So the spring action is pretty good, but the lateral movement is their serious problem with this design. So I needed to get a better design than this. Well, the next designs I came up with was this design, which worked again pretty well, and it was using felt pins. And these felt pins just slide into this housing and then get clamped in place with some set screws. And this worked pretty good for printing with the felt pins, but I have no spring action on this. And if you put too much pressure on it, the felt tip flattens. So this system worked pretty well, but it still isn't the optimum solution. So this is one of my next designs. So it uses a felt pen, or it could use a Bic style pen. Either one would work. But again, the pen goes in this housing, and it does go in here, and it will have a spring to movement. But there's way too much friction on this. The system is designed with a block mechanism that slides on this cylinder. And it does slide, but there's too much friction, and it would take too much pressure to keep the pen in constant contact with the paper. So it was a good concept, but it didn't work that well. So next I came up with the concept of using these linear bearings. I've used these in previous projects, and they work nice because you can put a cylinder in here, and it rides on roller bearings inside this cylinder, and you get nice, smooth motion with minimal friction. So this is probably a good idea for longitudinal movement of my pen back and forth. So I developed this first prototype using this large linear bearing and using these two pen holders. One uses a regular Bic pen, the other uses a felt pen. There's a spring in the bottom, and this just slides in there and gives me, some constant pressure. So this keeps the pen, against the paper. Works pretty well. Lateral movement's pretty good. There's very little lateral movement because of this this linear bearing. There's very little movement with the cylinder. It's a pretty tight fit, so there's no really lateral movement of the pen tip. So that works pretty well. A little bit big and bulky. So that was my first prototype, and I used this idea to develop my final design. This is my final design, which I call a spring-loaded pen for the Rose engine. It uses a linear bearing, but these linear bearings are much smaller than the linear bearings shown in the previous design. I designed this assembly to use inexpensive Bic pen cartridges. The pen works by the pen sliding inside the linear bearing with a spring at the base of the pen, and this maintains a constant pressure of the pen tip against the paper surface. There's about 1/4 of an inch of pen movement, and there is no lateral movement of the pen tip. So that was my final design using the linear bearings, using a Bic pen refill. I'm quite happy with the results. This is my optimum design. I have good, pressure against my paper. There's no lateral movement of the pen tip. It just seems to be the optimum design. So I'm quite happy with this design. The spring-loaded pen was designed using the Fusion 360 software. There are 9 individual parts or components to this assembly. I will describe each of the components and show how the system is assembled. At times I'll show a cross-section of the assembly so you can better see how the assembly fits together and operates. The first component is the pen holder. This pen holder was designed to hold a Bic pen refill and is about 4.5 inches long. It has a hollow interior to encompass the Bic pen, and it has an enlarged cap at its base. This enlarged cap will be needed to limit the travel of the pen insert. The outside diameter of this pen holder is exactly 8 millimeters, which is the interior diameter of the linear bearing into which it will slide. The Bic pen is next inserted into the pen holder. This cross-section shows the Bic pen refill fitting inside the pen holder and extending its entire length. Next, I add the linear bearing. This linear bearing enables the pen holder with a big pen attached to easily slide back and forth inside the linear bearing with minimal friction or resistance. Since the pen holder fits snugly inside this linear bearing, there is no lateral or sideways movement of the pen. This ensures accurate printing. This linear bearing has an inside diameter of 8 millimeters, an outside diameter of 15 millimeters, and it is 45 millimeters long. This linear bearing will later fit snugly inside the main body housing for the spring-loaded pen. Next, I add the spring assembly. The spring assembly consists of 3 components: the 12 millimeter long spring and 2 end caps. The 2 end caps are attached to the 2 ends of the spring. Finally, I add a screw plug to the end of the assembly. This screw plug enables the adjustment of the spring tension should it be needed. I then insert all the components inside the main housing for the spring-loaded pen. This housing is 3/4 inch in diameter and is 6 inches long. It's designed to fit inside an AXA boring bar tool post holder. This cross-section shows how all the components fit inside the main housing. The linear bearing fits snugly inside the left end of the main housing. The right end of this main housing has a 1/2 inch by 13 thread per inch thread for the attachment of the screw plug. Rotating the screw plug enables the adjustment of the spring tension should it be needed. There is a lip inside this main housing which limits the travel of the pen holder with the big pen. Finally, I add the AXA boring bar tool post holder. This tool post holder has a 3/4 inch hole in its side into which the main housing is slid and then clamped in place. And this completes the assembly of the spring-loaded pen assembly. Here's a visual description of how the spring-loaded pen tip operates. The big pen is securely fixed in place inside the pen holder. This pen holder can then slide back and forth inside the linear bearing with a total movement of about 1/4 inch. The linear bearing provides for minimal friction or resistance on the pen holder, and therefore the pen holder slides back and forth inside the linear bearing with no resistance. Since the shaft of the pen holder is exactly the diameter of the linear bearing, there is almost no lateral or sideways movement of the pen. Therefore, the pen operates smoothly and accurately when printing the design patterns on both the faceplate and side plates for the Rose engine. This cross-section view shows the interior movement of the pen. The enlargement at the base of the pen holder and the lip inside the main housing limit the movement of the pen holder, and the spring just keeps a constant tension on the spring tip against the paper into which it is writing. This will ensure that if there is any inconsistency on the surface of the place into which the spring-loaded pen is printing, the pen will stay in constant contact with the paper surface with a constant pressure to assure accurate printing of the patterns on the paper. I'm now ready to assemble the spring-loaded pen system. There are 9 parts or components that were described previously. The pen holder, the main housing, and the spring caps were all printed out using my Bamboo 3D printer. The linear bearing, the AXA tool post, and the spring were all purchased from Amazon. The screw plug was purchased from MasterCard. I'm using an ink refill cartridge that was removed from an inexpensive Bic pen. The linear bearing was previously press fit into the main housing. Likewise, the ink refill cartridge was also previously press fitted into the main pen holder. The pen holder with the ink pen is then inserted into the bottom of the main housing. The spring and the 2 end caps is next inserted, and everything is held in place with a screw plug. The screw plug is then screwed into the base of the main housing. Here you can see the small movement of the pen holder in the main housing. I slightly loosen the screw plug to increase this movement. The entire spring-loaded pen assembly is then inserted into the 3/4 inch diameter hole in the AXA tool post, and it's then clamped in place by tightening the 2 screws on the AXA tool holder surface. In this first example, I'm using a spring-loaded pen to print a rosette pattern on an index card which has been attached to the aluminum faceplate which I previously made for my Rose engine. This index card is held in place with 4 small magnets. This aluminum faceplate was described in a previous YouTube video. I'm using a 12 sine wave rosette with an amplitude of 0.25 inches. I'm printing a total of 6 rosette patterns, starting at 0.001 inches and spacing each successive pattern by 1/4 inch. After the 6 patterns were finished, I then rotated the rosette by 1/2 of a sine wave and then printed 6 additional rosette patterns, starting at 0.125 inches and then printing each successive pattern by an additional 1/4 inch. This will print patterns between the previous patterns which were just finished. This section of the video was sped up 10 times the actual printing speed to reduce your viewing time. I then removed the index card from the faceplate, and this is the finished printed pattern. In this next example, I'm using the spring-loaded pen to print out a sine wave pattern on the sides of a cylinder. I'm printing 80 sine waves per revolution with an amplitude of 0.25 inches. I'm printing 6 successive layers, each layer spaced 0.25 inches from the previous layer and phased by 1/2 of a sine wave. This section of the video was sped up 10 times the actual speed to reduce your viewing time. Notice that the pen prints cleanly and evenly with no spaces or gaps. I've been quite pleased with the performance of this new design for the spring-loaded pen. The spring tension on the pen tip keeps the pen in constant contact with the paper surface with an even pressure, which enables a smooth printing as seen here. After designing and testing many other designs of pens for printing patterns on a Rose engine, this is by far the design with the best performance. After the printing was finished, the paper strip was removed from the cylinder. And here is a finished pattern created and printed with this new spring-loaded pen. This concludes this video on the new spring-loaded pen for printing patterns on both the face plates and the side cylinders on the Rose engine. The pen was designed using the Fusion 360 software. This pen design was a final and best design after I previously designed and tested several other designs. The pen tip slides back and forth about 1/4 inch, which keeps the pen tip in constant contact and pressure on the paper surface. Thank you once again for watching this video. If you have any questions, concerns, or comments, leave them in the comment section below or send us an email. And thank you.